at different points how the potential would be. Suppose if we consider this as the radius, at the inside point, students' potential is given by KQ, if the total charge is Q here on the surface, KQ by R, R square minus small r square. The charge is entirely like this. By 2r, 3 capital R square minus small r square by 2r. And students, at the center here it is equals to 3 by 2 k q by capital R. And students, at the surface it is k q by capital R. And which is at a distance r, at this point it is given by k q by r. Students, I kept it in a very simplified version. This is for a solid sphere. Okay, non-conducting. In the case of a non-conducting sphere, non-conducting uniformly charged sphere. Non-conducting uniformly charged sphere. These are the results. 2 capital. Yeah. It is 3 by 2. Students, you understood, ma? I told you about 4 points. This is the center point potential, and this is the internal point potential, and this is the point on the surface, and this is a point at a point outside, at a point outside. And similarly, students, in the case of a shell, uniformly charged conducting shell, in the form of a uniformly charged conducting shell, where charge is given besides only on the outer surface. These are the points. Now, students, here center, inside point, surface point, and on an outside point. Students, inside point, surface point, and center point, all will have what potential? KQ by capital. Is it or not? KQ by capital. And for an outside point, at this one, which is potential by K small q divided by small. So these are the cases. I'll tell you once again. V inside potential is equals to V center potential, and that is equals to surface potential. Is it not the summary what we discussed, students? Please. So this is the summary, students, the brief summary. Yesterday, total almost half an hour is spent on this one, and we mentioned you the formulae how to derive these cases. Now, if you see the graphical discussion of these cases, friends, in this case, the graph would be like this. So these are having two types of trends. This is the center, r equal to 0, small r equal to capital. This is small r more than capital. At this point, small r is less than capital. This point and this point is equals to 3 by 2 Vs, and this is Vs. However, in this case, the potential relation with respect to distance is given by V. Center, inside, and surface. If you see this one, for every point inside, center, and up to the surface, the potential is same, and thereafter it will be changing V proportional to 1 by R, like this. And at this point, this potential is maximum, that is KQ by R. Student, center potential or inside potential is always equals to surface potential. My students, this is the summary related to uniformly charged non-conducting sphere and uniformly charged conducting spherical shell. Now, let us see, students, in this case, how we can write the potentials for various discussions, various concentric spherical shells. various concentric spherical. Yeah, Charan Babu, syllabus is completed, but some important points are there, which I need to mention. Please stay till the end of the class. Students, it would be very, very useful. But don't think that syllabus is completed, sir is revising this one. Small points have missed, and they will be discussing now, which are very important for the tomorrow's examination. If you remember these points, students, if you remember these points, it is enough for solid sphere and shell. This is a consolidated short notes form. Bacho, is this clear, ma? You might have seen, yes, Nagendra, you might have seen the lengthy derivation. Yes, Pallav Reddy, it is good if you take the screenshot of this one. Pallav Reddy, yeah. Yes, Rajkumar, very good, Sai, right. Isn't it useful to you or not? All the points are marked in one formula. Yes, good. Center point, center of the sphere, inside point, surface point, outside point. So this is a very comprehensive discussion of these things. So consolidation, I mean to say this consolidation is very, very important. This consolidation is very, very, very important. Yes. Now students, find the potentials. Find the potentials at A, B, C, D, E. Okay. So I'm marking some points. Please try to identify at these points we need to mention the potentials. This is one shell. This is another shell, and this is another shell. Like this. 3 shells are there, students. So based on these 3 shells, we need to find the potentials where we the points will be marked A to G here, and we need to find the potentials at these points. So let us say this charge is Q1, this charge is Q2, and this charge is Q2. Q1, Q2, and Q3. Q1, Q2, and Q3. And the respective radiuses, if you see here, this is A, this is B, this is 3 concentric spherical shells of radii A, B, and C. And the point, students, what we have considered are taken from the outside. Let us say, students, this point is A. This point is A. B on the shell, outer shell. C here. D is a point on the inside. E here. F here. And G here. Students, can you see these points? A, B, C, D, F, G. These are all taken. A. Point A is where, students, point A is where? Outside the 3 shells. Outside the 3 shells. Now tell me, students, what is the point lying on the inside the inner shell? Inside the inner shell is what point? Inside of the inner shell is what point? G. Surface of the inner shell. Surface of the inner shell. F. Between inner shell and second shell. Between inner shell and the second shell. E. On the surface of the second shell. on the surface of the second shell. D. Between outer and the second shell. Between outer and the second shell. C. Surface of the outermost shell. Surface of the outermost shell. B. Okay. But students, you know the addresses of these points. Now, at these points, students, we need to report the potentials. Okay, ma? Okay, students, let us see. And from here to here, students, this is the center of this distance is given as R. Let us this is equals to R. From O to A, the distance is R. From O to R, the distance is from O to A, the distance is R. Let us say from this point to this point, the distance is R1. From center O to this point E, the distance is R. Now, students, we need to write the potential at point solution. Potential at A is given by students. What is A point? A is the external point. A is the external point to all the three shells. So, A is at a distance of R. So, for an outside point, what is the potential? Because of the first shell, K Q1 by R plus K Q2 by R plus K Q3 by small r. Students, is that clear, ma? Please see this one. Potential. This is potential at point A. A is an external point. A is an outside point. When A is the outside point, the charge is Q1. Bacho, is that good? Vivekananda, Altaf, everyone understood, ma? Hardeep, very good. Am I everyone? Everyone. Why I have written like this, students? Because capital A is a point lying. Because capital A is a point lying. Jagan, Sai Pradeep, very good. Capital A is a point lying outside. It is a point lying outside. Very good. Now, at a point B on the surface, students, potential at a point B on the surface. So B, yes, Srinivas, very good. How to write the potential B at a point on the surface? Point B is a point on the surface of the outer shell. Students, for the surface of the outer shell, how we have to mark? So this is K Q1. What I should write in the denominator? Bacho, please tell Srinivas, other students. Girivardhan, should I write R or C? Shashank is giving the answer. Bache, C is O to B distance is what? C. C, very good. And B is the outer point. B is the outer point for which two shells? Students, capital B is a point which is outer to which two shells? Inner shell and the second shell also. Yes, very good, Vivek, very good. So that means for an outer point, it is K Q2 by C plus K times Q3 divided by C also. Okay, understood, ma? Is this clear, bacho? Students, B is a point. B is a point on the surface of the outer shell, but outside of the first shell and the second shell. No, I didn't write. This is C. This is C. Now let us go for point C. Students, C is a point. Bacho, please tell me. C is a point. At this point C, I have to write the potential. How to write the potential at point C? Yes. Please, okay, before writing the formula, please tell me C is what? C is an outside point for inner one and second, first and second. Capital C is the inner point for the inner shell and the outer shell. So that means for the inner shell, we can write KQ1. Yeah, KQ1 divided by R1 plus K Q2 divided by R2. Yes, this is R1 Now, bacho, this C is the internal point for the, this C is the internal point. So for a shell, if I say this is the center, at this point, this is the shell, 20 volts. What is the potential here, bache? Students, if this is 20 volt, what is the surface potential? 20. Very good. So can I say now, students, can I say now, inside the potential is always equals to 20 volts. So at this point C, what is the potential? What I have to write? A Q3 upon C. Please see, due to the charge Q3, what is the potential at C? C is an internal point. So internal point potential will be always equal to surface potential. If internal point is potential 20 volts, surface is also 20 volts. Shashank, other students, you are following the class, ma? Shashank, other students, you are following the class? Right, very good. Now let us concentrate on fourth one. Let's clear, sir. Very good. Question, point number D. Okay, please concentrate. D point is what? But D is a point lying on the surface of the inner shell. So A and D point is the outside point to the inner shell, surface on the second shell. Very good. K Q1 divided by B plus K Q2 divided by B plus K Q3 divided by C. Now please check whether it is correct or not. Is this correct, ma? Students, point D is the internal point. Point D is the internal point for the shell C. Because of charge Q3, what is potential at D means internal point potential is equals to outside potential. Now, point E, students, point E. Bacho, capital E is a point internal to the second shell. So that means we can say that here A Q upon R2 plus K. What I have to write, ma? E. Capital E potential. Yes, an internal to Q2. Very good, an internal to Q2. So we have to write K Q2 divided by B, and this is K Q3 divided by C. Yes, Altaf, very good. I'm glad students, many of the students are giving the correct answers. I'm appreciating your understanding. I'm very much glad and appreciating your understanding. I love you all students. Super, well done. Now let us concentrate capital G point. Capital G point. Students, at capital G, potential at a point G now. So, okay, F, first of all, F point. Students, F is a point where F is a point lying on the surface of the first shell. So K Q1 divided by A plus K Q2 divided by B plus K Q3 divided by C. Bacho, is this clear? Right. Now one more point is there, G. Students, seventh point. Potential at point G is equals to what? Yes, internal of the first shell. So for an inside point means it is equal to surface potential. So that is K Q1 by A plus K Q2 by B plus K Q3 divided by C. Yes, the same as F. Very good. VF equal to VG. Your friends are telling that, sir, VG is equals to VF. But so is it not? Yes, Tejram, very good. VF is always equals to VG. VF is equals to VG. Yes. also equals to BO. Bacha, understood ma? Also equal to potential at the center O, concentric point of all the three shells. Yes, students, very good, comfortable. Students, I appreciate your performance. Ma 2776 B also. No. So inside point, G point, and yes, VO also lies an internal point to the first shell. Is it a conducting? Yes, ma, it is a conducting. I said it is a shell. I said these are all shells, conducting shells. Conducting means will the charge lies on the volume of the body or the surface of the body? When I say conducting, the charge will lie on where? Entire volume of the body or on the surface of the body? Very good. Surface, sir. Very good. Very good. Ma, please copy down, ma. Students, please copy down. Okay. Can I wipe and go to the next topic? Students, can I wipe and go to the next topic? Irfan, Hardeep. Yes, sir. Okay, done. Rajkumar, very good. Very good. But 17767 Srinivas are asking to wait for 1 minute. Okay, please copy down quickly, ma. So can I wipe, ma? Okay, students. Right. Students, I appeal everyone sincerely to stay till the end of the class. Don't miss the class. Till 8:45, all important points I will be touching. So please don't leave the class. Three concentric shells ABs. Students, question. Three concentric shells A, B, C have radii A, comma, B, comma, C, A less than B less than C, with surface charge densities. With surface charge densities sigma, minus sigma, and plus sigma respective. Sigma, minus sigma, and plus sigma respective. Find potential of A, potential of B, potential of C. These are the key points here. Now, students, let us say the three concepts. This is one shell, the second shell, and the third shell. This is the concentric point A, B, and this is. Students, what is the charge on this one? This charge is Q1, this charge is Q2, and this charge is Q. But so you all know that sigma is equals to charge upon area. Then charge Q can be taken as sigma times area. Friends, I repeat, this charge is Q1, this charge is Q2, like this. So what is Q1 now? Solution, Q1 equal to sigma times area 4 pi a square. Q2 equals to sigma minus sigma times 4 pi b square. And Q3 is equals to plus sigma times 4 pi c square. Is that clear, ma? Students, you know the habit of writing the charges in terms of sigma and area like this? Right, very good. Now, first point for VA, VB, and VC. We should mention about VA. So, how to write potential V? Students, the first part of the question, VA is equals to potential on the surface of the shell. Now, when I say VA, potential on the surface of shell, A, surface point Q1 divided by A. Next step, Q2. Students, Q2 plus Q2 divided by B. Yes, very good, Irfan. Irfan 7767. Please share your views now. 7767. One student, please share your views. Then you can get a point. Yes, very good, Irfan. And other one is Q3 upon C. Q3 upon C. But so is that clear? Yes, very good. Amma understood 7767 now? All the students understood well except one student, this guy, and that guy also able to follow now 7767. Love you all, my students. Good. Now, students, this is now equals to. Somebody came with my name. Okay. Now, if you put K as 1 by 4 pi epsilon naught, Q1 is equals to sigma times 4 pi A square by A. And this is Q2 minus sigma 4 pi B square by B plus sigma 4 pi C square upon C. Students, is this clear, ma? Bacho, is this clear? So therefore, potential at a point on the surface of the shell, VA is equals to 4 pi will cancel out everywhere. 4 pi will cancel out everywhere. So sigma upon epsilon naught. Students, sigma upon epsilon naught times what is left? What is left here? 4 pi will cancel. 4 pi will cancel everywhere. So therefore, A minus B plus C. Is it or not? Very good. A, very good, students. A minus B plus. Right, very good. Now, second point, students. Potential for the shell. For the shell B. Shell B is here. Shell B is here. So this is K Q1 divided by. So students, B is a point lying on the surface of the shell. On the surface of the shell. So this would be equals to. How to write now? In terms of charge you mentioned. This is Q1 upon Q1 upon what I have to write? Yes, B plus Q2 by B plus Q3 by C. So K is equals to 1 by 4 pi epsilon naught Q1 sigma 4 pi A square divided by B plus B sigma 4 pi B square by B plus sigma 4 pi C square by C. So therefore, now what happens? But please see now. 4 pi will cancel out everywhere. 4 pi will cancel out everywhere. Yes. Sigma by epsilon naught. Sigma by epsilon naught. A square minus b square by b plus c. I hope it is clear, Bacho. Students, I hope it is clear to every one of you. Students, is that obliged? Is that okay to you all? Perfect. Now, students, the last one. Potential at a point on the surface of the shells. So K times, students, K times, C is a point here, C is a point, this is B, this is B. C is a point internal one. Right. So Q1 plus Q1 by C, Q2 by C plus Q3 divided by C. 1 by 4 pi epsilon naught Q1 sigma 4 pi A square by C sigma 4 pi B square by C plus sigma 4 pi C square by C. Now what happens, students? 4 pi will cancel. So this implies sigma upon epsilon of A square minus B square plus C square whole divided by C. Is that clear, ma? Yes. Crystal clear, sir. Yes, very good, Shai Shashan. Now, students, a small another continuation part is there. Fourth question in the above question. If VA is equals to VC, relation between A, B, and C. Students, they said that if potential VA is equal to VC, what about the relation between A, B, and C? Equate this potential and this potential, students. Yes, very good. Let us see now. VA equal to VC. Students, if we write VA equal to VC, what would happen? VA equals to VC. Sigma by epsilon naught times A minus B plus C. Sigma by epsilon naught A square minus B square plus C square whole divided by C. Sigma by epsilon naught cancel. So this becomes cross multiply. AC minus BC plus C square is equals to A square minus BC plus C square. So therefore C cancel, C common, A plus B into A minus. So this implies C equals to A plus. And this is a very, very important. Very good. Am I understood this point? Such questions would be discussed till 8:45. Please be available. Please be available till the end of the class. Okay. Students, can I write VA, VB, VC? Students, can I write VA, VB, VC, everyone? Right. Students, in the coming week, you are having examinations. I will make your work easy, students. Students, I will make your work easy by discussing the chapter briefly once again on Tuesday and Thursday, students. On Tuesday and Thursday, I will be briefing. On Tuesday, I will be briefing electric charges, and on Thursday, I will be briefing about the magnetism and matter. Okay, I will make your task easy, students. If you listen to the class and now you proceed, go for self-study, half the job will be done from my side, and the remaining half job, you complete that one. Right. Right. Okay, done, ma. Another question. A charge capital Q is uniformly distributed on two concentric shells of radii A and B within brackets A less than. Find the potential at the center if their surface charge densities are equal. Find potential at the center if their potentials are equal. So this is the key issue, students. Students, here this is one concentric shell, this is another concentric shell. This is point, this is A and this is B. This charge is Q and this charge is Q. The surface charge densities are equal. This is sigma and this is also having sigma. And in this case, students, this is a concentric point O. The charge capital Q is divided into two parts. This is Q1 and this is Q. Now tell me, student, based on conservation of charge, what is the relation that can be established? If charge Q is distributed between the two concentric shells Q1 and Q2, Q1 on the inner shell A, Q2 on the outer shell B, capital Q, based on the conservation, it is equals to what? No, we can't say equally divided. Rajkumar, if their dimensions are same, Rajkumar, then we can say that Q by 2, equally. So here, capital Q, the total charge, according to additive property, it is equals to Q1 plus Q. Why is it R? Q1 plus Q. Sum of the two charges. Yes, Shravan Kumar. Sum of the two charges. Now they said that surface charge density, given that if their potentials are, if their surface charge densities are equal, surface charge densities are equal. So sigma of the inner shell and sigma of the outer shell both are same. That is Q1 divided by 4 pi a square, Q2 divided by 4 pi b square. Therefore, Q1 upon Q2 is equals to A by B whole square. Understood, ma? So 4 pi will cancel here. So Q1 upon Q2 will be equals to 4 A upon B whole square. So potential at the center, students. Potential at the center is equals to V1 plus V2. So this is equals to K times Q1 divided by A and Q2 divided by E. Like this. So K 1 by 4 pi epsilon naught. So this Q1, students, if you see this Q1 is equals to A square divided by A square plus B square times capital. Q2 is equals to B square divided by A square plus B square into capital. Now this is the point. Students, Q1 upon Q2 is A square by B square. Suppose if I say X upon Y is equals to 1 by 2, what is X means? You will be writing 1 plus 1 by 2 times this you have to write. Is it or not? X by Y means 1 by 2. X by V is 1 by 2 means X equals to 1 plus 3 times Z. This is Z. So similarly, Q1 is equals to A square like this. Now put these two values here. So Q1 is equals to A square divided by A square plus B square, capital Q divided by small a. Q2 is equals to B square divided by A square plus B square, capital Q divided by P. Now, any cancellation, students? B will cancel, A will cancel. So this happens here now. Q upon 4 pi epsilon naught times A plus B divided by A square plus B square. Now please see this one. Is this clear to every one of you? Deepesh Kumar is asking how Q2 value is obtained and Q1 value is obtained. Deepesh Kumar, Q1 upon Q2 is equal to A square by B square. You add 1 on both sides. Add 1 on both sides. And if you follow these lines like this, you'll be getting Q2 value here. Okay, you'll be getting Q2 value here. So similarly, if you reverse the, if it's Q2 here means B square. Then Q1 here means it would be A square. So Q1 equal to A square, Q divided by A square plus B square. Am understood? Deepesh Kumar, right. Okay, can I wipe the board, students? Have you taken down? Done, sir. Shravan is taking. Shravan, please take it down. Rajesh, it is not required mark. It is a something different concept. Now here, this is A and this sphere is B. Two metallic spheres of radii and they are connected by a connecting wire. Two spheres of radii A and B are connected by a connecting wire. Are connected by the connecting wire. Charge Q is given to any one sphere. Charge Q is given to any one sphere. Two spheres of radii A and B are connected by connecting wire. I will be discussing earthing of the conductor. Please write. Charge distribution and earthing of the conductor is the thing that is there to discuss. I will be discussing that. Find the ratio of potentials. Find the ratio of potentials charges, surface charge density, electric field intensity. Now, these are the things that are to be discussed. Potentials, charges, surface charge density, and electric field intensity. Potential V, charge Q, this is sigma, and this is field intensity. Students, if this is one sphere and another sphere of radius A and radius B, and the two are connected like this. When connected with students, when connected with a wire, charge transfer takes place. Till what happens? Charge transfer takes place between the two shells. Till their potentials are. Now what happens? The charge will transfer between the two spheres. Till their potentials becomes equal. Very good. Equal. The charge transfer, when connected with the wire, charge transfer takes place till their potentials are equal. Till their potentials are equal. So the first point is that if final potentials V1 is equals to V2, then that means V1 is to V2 equals to 1 upon 1. Is that okay? Now students, from this V1 is nothing but K Q1 dash divided by radius A, K Q2 dash divided by radius B. So the ratio of the charges on them, Q1 dash upon Q2 dash is equals to A upon B. A upon B. Students, potential V1 is equals to, suppose on this one the charge is Q1 dash, on this one the charge is Q2 dash. And the sum of these two charges, Q1 dash and Q2 dash, it should be always conserved and it should be always equals to Q, capital Q there. Now the third point, students, is that what is sigma? Now what is sigma then? So in this case, students, I can say that Q1 dash is equals to A divided by A plus B in terms of total charge capital. And the second charge, how to write second charge now? Q1 dash means A divided by total into B. Q2 dash means B upon total number of parts times B. Yes. B by, right, very good. So similarly, third one, sigma. Sigma is charge upon area, that is 4 pi into radius square. So therefore, sigma is proportional to charge upon radius square. Therefore, sigma 1 upon sigma 2 is equals to Q1 dash by Q2 dash into B by A whole square. So Q dash by Q2 dash is A upon B. This is B by A whole square. So this is B upon A. B upon. Point 4, electric field intensity. Friends, electric field intensity capital E is equal to A Q divided by radius square. So capital E is proportional to Q divided by R square. So sigma and electric field both are having same thing. So hence you can say, students, E1 upon E2 can be also taken as, please tell me, E1 upon E2, as these two are like. So what we can say about, similar to sigma 1 upon sigma 2, E1 by E2 is our getting very good. This is E upon E2. Right, very good. Okay, please can I clear, sir? Right. Students, can we wipe the board? Bacho, can I please take the screenshot? Nagendra wants 1 minute time. Yes, Rajkumar, please take it down. I will wait for 1 minute. Irfan said finish. Right, okay, Srinivas. Students, one important point. If smaller number of charged drops combine each of charge Q combine to form a big drop of radius capillary, then for a big drop, what is the total charge? What is the potential? What is the field intensity? What is sigma bigger? B stands for bigger. So students, here these many drops are there. Each is having a charge Q. When they are combined, they form a total charge capital Q of radius capital. According to charge conservation, the charge cannot be created. The total charge on the big drop will be say always equals to sum of the charges of all these. If there are 3 charges, Q, 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 and this big charge will be equal to 3. But here n number of drops are merging, n number of identical drops are merging, each of charge q, q, q. Then the total charge of the bigger drop would be equal to nq. And also, according to the conservation of mass, here, mass is equals to density into 1. As density is constant, mass is proportional to 1. So that means volume of n small drops is equals to volume of one big drop. So this means, students, n into volume of smaller is equals to 1 into volume of the bigger. So n into volume of smaller means 4 by 3 pi smaller cube 1, 4 by 3 pi capital. 4 by 3 pi will cancel. So that means n small r cube is equals to capital R. That means capital R can be taken as small r n power 1 by. I'm understood, but this is a very key issue. And these rounded boxes are very, very important. Yes, Deepesh Kumar, we learned it in surface tension. We learned it, this one in the surface tension term. Now, so capital Q is answered. Capital Q is equals to n times small. Now, what is bigger? Potential of the bigger. Students, potential of big drop on the surface VB is equals to K capital Q by capital. K, this is n small q by capital R is nothing but small r times n power 1 by. So K Q by small r n power 1 minus 1 by. So therefore, n power 2 by 3 into V small. Understood, ma? So therefore, potential of the big drop is equals to n power 2 by 3 into V small. And this is a very, very important. Potential of the bigger is equals to n power 2 by 3 into V smaller. This is a very, very, very important. So this is also solved now. So that is n power 2 by 3 into V smaller. Now let us go for electric field intensity. Students, electric field intensity on the surface. Electric field intensity on the surface. Third point, E big is equals to K times capital Q by capital R square, A n q capital R small r into n power 1 by 3 whole power, like this. So this is n K Q by R square, n power 1, n power 2 by 1 minus 2 by 3, K Q by R square. So that is n power 1 by 3 into E small. Understood, ma? So E bigger is equals to n power 1 by 3 into E smaller. N power 1 by 3 into E smaller. Now, students, we have to go about sigma bigger. Sigma bigger means what? What is sigma bigger? Fourth point, sigma big is equals to capital Q by big A. So this is n capital Q. This is 4 pi. Capital R is small r times n power 1 by 3 whole power. Yes. So Q upon 4 pi r square into n divided by n power 2 by. So this is sigma smaller n power 1 by. So sigma big is equals to like this. Same as E. Very good. So this is n power 1 by 3 into sigma small. But to arrive at these results, friends, to arrive at these results, these are the two that are very, very important. These are the two that are very, very, very important. Please take it down, students. I suggest you to take the screenshot. I suggest you all to take the screenshot. Over, sir. Okay. We took, sir. Right. Good. Students, can I wipe this lower part? Friends, here, if number of drops are 27 and smaller potential is equals to V, what is the big potential? Now find this one, students. If number of drops are 27 and Vs is equals to V, find V bigger is how much? V bigger is equals to n power 2 by 3 into V. 27, 2 power 2 by 3 into V. 3 cube whole power. So these two will cancel. 3 square into V, that is equals to 9. Very good, ma. Done good, ma. Students, at the end of the day, you have to remember these 4 points. Ma. These 4 points, if you remember, you can point out anything. You can point out anything. You can do anything. So at the end of the day, you should remember these 3. Students, capital R, radius, sigma, E will have n power 1 by 3. Potential will have n power 2 by 3. You do remember that one. Capital R, sigma, E will have n power 1 by 3. Potential will have V power 2 by 3. N power 2 by 3. Another question, ma? What amount of charge transfer will take place between the inner shell and the ground? What amount of charge transfer will take place between the inner shell and the ground? Students, here, this is the neutral body, this is Kepler, and this is Kepler 3R. This is a neutral because it is connected to the ground now. It is connected to the ground. Students, when it is grounded or earth, this implies that potential V is 0. It is connected to ground means its potential V is 0. Now, in this case, students, a charge capital Q is given to the neutral body. So options we are giving here. 4 options I am giving. We need to identify that. Minus q by 3 plus 2q minus 2q plus q by 3. Then this is the point. Now, as shell B is solution, as shell B is grounded, shell B is earthed, what happens to the potential of B? Shell B is grounded means its potential should be is equal to 0. Is it or not? Now let us say what charge is there on this one, we do not. On the inner one, what amount of charge is there, we do not know. Let x be the charge on the surface of this. Let x be the charge. So this becomes k x upon capital R plus capital Q upon 3R is equals to 0. So this implies, students, x is equals to minus capital Q divided by, is it R? Now, bachcho, please see. If this is having a charge, let us bring all these charges, capital Q, capital Q, capital Q. Am understood, students? Manas Kumar, Shashank, Irfan. So this charge is equals to minus Q upon. This charge is equals to minus Q upon. Potential of this inner shell is 0. VB is 0. VB is 0. Yes, understood, Srinivas. Very good. The amount of charge to be. So now, students, as inner shell, yes, inner is a neutral. Yes, inner is a neutral. To maintain neutrality, students, to maintain neutrality, what amount of charge should flow from the ground? That should be minus x. Is it or not? Minus x. Yes, ma'am. So F is minus of minus q by 3. So this is plus q by 3. Am understood, ma'am? This charge is plus q by 3. Hence, answer to this option is like this. Yes, same charge but opposite sign. Am understood? Yes, very good, Shravan. Okay. Yes, earth will be taken as no charge. It is a reservoir of charges. Earth will take charge, no, sir. Yes, ma'am. But to maintain neutrality, so inner is neutral. To maintain neutrality, the amount of charge should flow to the ground. From the ground, or then Y will give negative. Nagendra Babu, what amount of charge should flow from the students? Here it is having minus q by 3. From the sphere, from the inner one, what amount of charge should flow? Minus q by 3. So to maintain neutrality from the ground here, the charge flow should be opposite. Earth is a big reservoir of charges. Earth is a big reservoir of charges. If we add some charge or taken charge, its electrical status 0 will not change. Am understood, Nagendra? Right, okay. Now, students, we are discussing the problems on the charge distribution. Problems on charge distribution in concentric spherical. Students, as the first one, let us say that these are two concentric shells like this. Center. At this point, you kept a charge Q. This is of radius smaller. From the center, it is at a distance smaller. Let us say this radius is small a and this radius is small a. I'm understood, but that is the key point. A charge Q is placed at a distance. A charge Q is placed at a distance smaller from a conducting shell of inner and outer radii A and B. Of inner and outer radii A and B. Find the charge distribution on the outer surface of the shell. Find the charge distribution on outer surface of the shell. But this is the key point, students. Small q is the charge that is kept here. Students, this is small a. This is the radius of small a. Charge small q is kept at a distance smaller from the center O. From the center O. Inside the shell, students, initially this is neutral. Initially this is a neutral. Nothing is there. Charge is kept inside O. Charge is kept inside O. So if inside the shell, students, field is always equal to 0. Students, you know that inside the shell, what is the field? 0. When field is 0, flux is also 0. When flux is 0, charge enclosed is also equal to 0. Is it up? Charge enclosed is also equal to 0. So if we consider this charge is Q here, and let us suppose that this surface charge is, that is inside this surface, Q plus X is equals to 0, then the charge X equals to minus Q. Then this charge X is equals to minus Q. So that means, students, this charge is equals to minus Q. Am understood, ma? To maintain neutrality, so this is minus. But on the outer surface of this one, there will be another charge Q. And this charge, students, this charge plus Q to neutral. To maintain neutrality, ma, students, to maintain neutrality, because of this charge Q, an induced charge minus Q is appeared here. So to maintain neutrality, this minus Q and plus Q should cancel each other. Am understood, ma? Bacho understood? Shashank Babu understood? Right, perfect. Irfan, Rajkumar, very good, very good. Hardeep, are you there? Hardeep, are you there? Very good, ma. Good, ma. So this is plus 2 there. Now, if the outer, students, if I say, if the outer surface is earth, if the outer surface is earth here, then this charge, then the induced plus Q will pass through the ground. Will pass through the ground. That is here. Am understood, ma? This is minus Q. This is, suppose if I connect this one, students, if I connect this one to the ground surface like this, whatever the charge on the outer surface is there, yes. Earth is a reservoir. Earth is a reservoir of charge. So, students, on the inner surface, charge is x minus q. On the outer surface, it is minus x, that is equals to plus. This is inner surface, this is outer surface. This is minus q, this is plus. And these are induced charges. Students, these are all induced charges. Can I write, students? I request you to please take the screenshot of this. Done. Irfan Babu, have you taken? You took the screenshot? Shall I go for the next one? Right. Now, students, two concentric shells. Two concentric shells. Two concentric shells are there, like this and like this. This is given capital Q, this is A, and this radius is B. A and B. Now, how the charges will appear? Students, how the charges will appear? This is shell 1 is of radius A, shell 2 is of radius. For students, because of this, what charge would be there here and what charge would be there? Now, please tell me, if I mark this as X and this as Y, what is X, what is Y? But so due to induction, students, due to induction, X should be equals to what? What is X and what is Y? What is X, what is Y? This is the inner shell of radius small a and this is the outer shell of radius small b. Ma, please answer, ma. If I consider this as the Gaussian surface, this as the Gaussian surface 1. Solution. Students, in GS1, electric field is 0, flux is 0, Q enclosed should be 0. So nothing is there. Okay, done. But if I take this as Gaussian surface 2, in Gaussian surface 2, my inside field should be 0, flux is 0, Q enclosed is 0. Capital Q plus X is equals to 0, so X equals to minus. Is it or not? So therefore, this charge X should be equals to, this is minus. Yes. What about the Y then? So plus Q is the charge that is there on the surface of this. Yes. Am understood now? Students, you understood? Minus Q plus Q, how they are forming inductions? Okay. Now let us say 3 concentric shells. Students, now 3 concentric shells. 3 concentric shells. Point number 3, students, 3 concentric shells. Student, three concentric shells, shell 1, shell 2, and shells like this. Students, in this case, this is of radius A, B, and this is A, B, and C. Capital Q charge is given to the inner shell. Capital Q charge is given to the inner shell and to the outer shell. And shell B is now grounded. Shell B is grounded. Students, let us say this charge is Q1 and this charge is Q. Shell B inner charge is Q1, shell B outer charge is Q. So because of induction, this charge on this surface, this charge will be minus Q2. And to this charge, plus Q2 should be taken. Is it on? Now, bacho, please see charge distribution now. Capital Q and capital Q. Q is given to inner, capital Q is given to inner and outer shells, and shell B is grounded. Shell B is grounded. My student, this is the story. So when shell B is grounded here, my student, shell B is grounded. When shell B is grounded, potential of shell B should be equals to what? Very good, zero, Vivek. Yes. Now, if you try to obtain the potential, how to write potential B, students? Potential B. Student, this is a point on the shell B. At this point, you have to find. B is a point on the surface. So this is K. K is taken as common. VB is 0. Okay, let me be very clear. VB is 0. Students, this solution is very crystal clear to all. All the discussion what I am making is a very crystal clear solution. So there is no ambiguity. Hope everyone is receiving in a positive note. Please try to identify the importance of these things. So VB 0. Students, when I say VB 0, potential B is 0. So capital Q, but this charge is inner one. This charge is inner. Capital Q by B plus small q by B. Small q1. Now, based on previous problem, students, based on previous problem, what is Q1? Students, what is Q1? What is Q2? Bacho, please answer. Yes, very good. This is minus Q and this is plus. Minus Q plus Q, right. So that means, students, you can consider this charge as minus Q. This is the inner charge, like this. So Q1 is nothing but here minus Q divided by B plus Q divided by B. Next. This charge is minus Q2 minus Q divided by C minus Q divided by C. Capital Q plus Q2 outer charge, how it is formed, we do not know. Plus Q2 by C. Students, any cancellations are there? Let us say this charge is Q2 only, this is the induced one. We don't know what is this charge. Let us say Q2 only. Then this is a shell beam. We do not know what charge is there. Students, we can't say this is of radius B. We cannot say that Q2 is equals to minus. Based on the previous problem, this outer charge will be leaving here. The outer charge because of this one will be leaving, and because of induction, this is minus Q2. This would be plus Q. Now please check any cancellations. Q by B minus Q by B will cancel. Minus Q plus Q will cancel. This implies Q by B minus Q by B, Q2 by B. This is Q2 by C. Now this charge is minus Q2 divided by C. Now once again I am telling please see, this is plus Q. From the zero level I am telling, please see, this is plus Q. Because of induction on the inner surface of the second shell, you will be getting minus Q. Though plus Q is formed on the outer surface of the outer shell, as it is grounded, it will be leaving. Now, on this shell, if it appears a charge minus Q2, this would be giving plus Q2. If this is minus small q2, the outer surface of the third shell will be plus q. So now what happens is minus q and plus q, both will cancel. Q2 by B is equals to capital Q divided by C. So this implies to students, charge Q2 would be is equals to, charge Q2 would be is equals to minus Q times B upon C. Okay, ma. Sir, one simple problem I will tell and then I will end the class, students. Yes, Abhishek, I am repeating. Abhishek, I will do one problem, then you can feel a lot of importance of. I will do one problem, Abhishek, based on this, then you can understand it very well. In the figure, students, the shell B, sphere B is here connected. Find the charges present on the inner and outer surface of shells A, P, and C. This is the question. Previously only A, B, C are the, and here the radiuses are given as, this is small r, 2r and 3r. Small r, 2r and 3r. These are the radius. And the charges given to this r. This charge is given a charge q and this is given a 4q charge. Students, q and 4q are given to inner and outer. Inner and outer. Now, students, if you see the charge distribution here, students, if you see the charge distribution, this is q. On the inner surface of this one, this will be having minus q. This charge would be minus q. Is it or not? On the inner surface of the middle shell, it is minus q. So students, if it is minus q, we are not sure what charge is there. This is plus q dash. This is plus q dash. And on the inner of this one, you will be having minus q dash. If this is minus q dash, this would be plus q dash. This charge would be plus q dash. Now potential of B is 0 as it is grounded. As it is grounded. So potential B0 means at this point potential is 0. So Q divided by 2R. This surface charge Q is at distance 2R at a point B and inner point also, plus minus Q divided by 2R, Q dash divided by 2R, plus minus Q dash divided by 2R, plus 4Q plus Q dash divided by, sorry, this is 3R is equal to 0. Am understood? Student, is this okay to everyone? Bacho, please see. Bacho, is this clear to everyone? This equation? Perfect. Shashank, are you there? Last 2 minutes, students. Last 2 minutes, I will end the class. So now in this case, this one will cancel. Q dash by 3R, will cancel. So therefore, what we are having is Q dash by 2R is equals to minus 4Q divided by 3R. So this implies, students, Q dash equals to minus 4Q divided by. Now, bacho, please see, is that okay? RR will cancel. Sorry, this is minus 8. Yes, minus 8. Abhishek, is that clear? Abhishek Babu, is that clear? Abhishek, clear? Okay. Now just, okay, sir. I must just take the inner and outer surface shells. Last 1 minute. This is shell 1, shell 2, inner, outer. Shell 1, shell 2, shell 3. Now please fill up these gaps. This is enough. Students, please fill up these gaps. If you fill up 1, 2, 3, 4, 5, 6, this is enough. This is enough. What is shell 1? Bacho, please answer. Amma, please fill up these gaps. 1, 2, 3, 4, 5. Chakas, jaldi karo, bacho. Students, please. Come on. Rajkumar, making you to experience these things I am taking, ma. So this charge is Q. Inner surface no charge. This is Q. This is minus Q. So this charge is plus Q dash. Plus Q dash means a minus 8Q by 3. This is minus Q dash. So it is 8Q by 3. So this is 4Q plus Q dash is. So this becomes equals to, student, this becomes equals to So therefore, this is plus 4q divided by. Understood, ma? So I end the class, students. I submit to you. Students, I submit to you. Bye, students. Bye-bye. Bye-bye. Bye, ma. Bacho, is this clear? Rajkumar, yes, I know that it is the time, but keeping in view of the importance of this, I extended. Rajkumar Babu, if something goes wrong, please excuse me. If extended for 5 more minutes, please excuse me. Bye, students. Bye-bye, everyone. Bye. Prepare for the examination. Prepare for the examination very well. Okay, no problem, sir. Bye. Okay, Rajkumar. Bye-bye. Rajkumar, bye, ma. Everyone.